After studying vapor pressure of a solution of solid in liquid and liquid in liquid, we are going to study ideal and non-ideal solution. Ideal and non-ideal solution based on the Rolle's law. Liquid and liquid solutions is classified into two types. One is ideal and non-ideal solution. So that is the liquid and liquid solutions. Liquid and liquid solutions are classified into two types based on Rolle's law. Based on Rolle's law, that is ideal solutions and non-ideal solutions. Ideal solutions and non-ideal solutions. These are the two types of liquid solution. These are classified on the basis of Rolle's law. Now let's take first one, ideal solution. So ideal solution is defined as the solution which obey the Rolle's law over the range of all concentrations is called ideal solution. Ideal solution. So ideal solution is defined as the solution which obey Rolle's law, over the range of all concentrations. Over the range of all concentrations is called ideal solution. Ideal solution. So observe, you know what is meant by Rolle's law. Now under all concentrations, the solutions which obey Rolle's law is called ideal solution. So ideal solutions is availability very rare. Means the availability of ideal solutions is very rare. Now for example, take ideal solutions, benzene and toluene. Benzene and toluene is the example for ideal solution. For these solutions, delta H of mixing, enthalpy change of mixing is equal to 0, and delta H of means not H, enthalpy change of a mixing is equal to 0, and enthalpy change of volume means volume change of a mixing is also equal to 0 for a solution. Means enthalpy change of a mixing is equal to 0, and change in volume mixing is also equal to 0 for a ideal solutions. Such type of solutions we call ideal solution. Example, benzene and toluene. Now observe, delta H of mixing is equal to 0. It means there is no change in enthalpy of mixing. Delta H of 0, it means there is no change in enthalpy, and delta is nothing but volume mixing. So ಯಾವುದೇ ಎರಡು ಸೊಲ್ಯೂಷನ್ಸ್ ಅನ್ನು ಅಥವಾ ಸಾಲ್ವೆಂಟ್ ಮತ್ತು ಸಲ್ಯೂಟ್ ಅನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ, when we are mixing solute and solvent you get solution. In such conditions, the change in enthalpy and change in volume mixing is 0. There is no change. It means 0. If delta H of mixing is 0, it means there is no absorption of heat or evaluation of heat, means liberation of heat. ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ, ಹೀಟ್ ಅನ್ನೋದು ಲಿಬ್ರೇಟ್ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ, ಅದನ್ನ ಡೆಲ್ಟಾ H of mix is equal to 0 ಅಂತ ಹೇಳ್ತೀವಿ. Similarly, delta V of mix is equal to 0, it means there is no change in volume. There is change in volume is equal to 0. It means there is no compression or elongation. It means expansion. There is no expansion and contraction of volume. in such solutions. Now example we are taking benzene and toluene. Benzene and toluene. Now observe if it is benzene. Let's take benzene is a component A and toluene is component B. Component B. Now if a component A, that is benzene and benzene. Benzene and benzene we are taking. This is a component 1. Let's take solute or solvent. Place the component B is taken as water. Toluene, that is B and B. There is number of particles in a benzene and also there is a number of particles or molecules of toluene in a compound toluene. ನಾವು ಬೆಂಜಿನ್ ಅಂತ ತಗೊಂಡಾಗ ತುಂಬಾ ಬೆಂಜಿನ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇರುತ್ತೆ, ಟಾಲಿನ್ ಅಂತ ತಗೊಂಡಾಗ ತುಂಬಾ ಟಾಲಿನ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇರುತ್ತೆ. Now these two are mixing together, you get a component of the type A and B. So after mixing benzene and toluene, you get a mixture of compound that is called solution A and B. Now observe here the interaction force, that is the interaction force between A and B. That is internal attraction between A and A is same as that of the internal attraction of B and B. Similarly, the internal attraction force between the means electrostatic internal attraction force between the A and B is almost same as that of the A and B and B. ಮತ್ತೆ A ಮತ್ತೆ B ನ ಮಧ್ಯೆ ಇರುವಂತ ಅಟ್ರಾಕ್ಷನ್ ಫೋರ್ಸ್, ಇವೆರಡು ಮಧ್ಯೆ ಇರುವಂತ ಅಟ್ರಾಕ್ಷನ್ ಫೋರ್ಸ್ ಅನ್ನೋದು A ಮತ್ತೆ A ಗೂ B ಮತ್ತೆ B ಗೂ ಸೇಮ್ ಆಗಿರುತ್ತೆ. Therefore there is no change in the delta H of mix and delta V of mix. This is happening in only ideal solution and the availability of ideal solution is very less, and such solutions obey the Rolle's law under all concentration of the solutions. Okay, this is called Rolle's law. Now similarly, some more examples for Rolle's law is take N-hexane and N-heptane and also ethyl bromide and ethyl bromide and ethyl chloride. Some more example for ideal solutions are N-hexane and N-heptane, that is normal hexane and normal heptane, and also ethyl bromide C2H5Br, ethyl bromide and ethyl chloride C2H5Cl. These are some example for ideal solutions. So observe here the properties of ideal solutions is the size of both the component, that is either you take solute and solvent. Solute ಒಂದು ಮತ್ತೆ solvent ಒಂದು ಅಂತ ಎರಡು ತಗೊಂಡಾಗ you get a solution. Okay, here the properties of both AA and BB is almost same, and the size of the AA and BB is almost same, and the internal attractive force between AA and BB is same. Therefore the resultant solution, internal attraction and their properties and their size of the particles is almost same to the AA and BB. Therefore the solution is called ideal solution which obey Rolle's law under all concentrations. This is the Rolle's law. This is the ideal solution. Then take non-ideal solution. Similarly, non-ideal solutions is nothing but the solutions. Non-ideal solutions is defined as the solutions which do not obey Rolle's law over the range of all concentration. Over the range of all concentration is called non-ideal solution. Okay, listen here. For non-ideal solutions is defined as the solutions which do not obey Rolle's law over the range of all conditions or concentration is called non-ideal solution. That is called non-ideal solution. Now similarly, for non-ideal solutions, take example acetone and ethanol. For non-ideal solution, take acetone and ethanol. Take for non-ideal solution, the example is acetone and ethanol. Or take example water and alcohol, or phenol and aniline. Or take chloroform and acetone. These are some example for non-ideal solution. Or take nitric acid and water. One more example for this one, nitric acid, HNO3 and water. These are the one more example for non-ideal solution. So observe in this case the change in enthalpy means delta H of mix is not equal to 0 and change in volume is also not equal to 0. Either means it shows either greater than or less than of the delta H. It means there is a change enthalpy and volume of mixing. So enthalpy ಮತ್ತೆ volume ಅನ್ನ mixing ಅನ್ನೋದು change ಆಗ್ತಾ ಇರುತ್ತೆ. It means it is greater than or less than equal to 0 but not equal to 0. Change in enthalpy and change in volume of mixing of solutions. Okay, now observe here in non-ideal solutions that we are taking two examples. A and A is a component solute and B and A component solvent. These two mixing you get a solution of the type AB. In this case of non-ideal solutions, the properties of AA and BB is not same and the size is also not same. Then similarly the internal attraction force between AA and BB is almost not equal to the AB. It means there is a large difference between the internal attraction between the AB and AA and BB. Okay, such type of solutions we call non-ideal solution. These doesn't obey the Rhodes law. Here delta H of mixing and delta V of mixing is almost not equal to 0. These are greater than or less than equal to this 0, not equal to 0. Such type of solutions is called non-ideal solution. Then again these non-ideal solutions are classified into two types, that is positive deviation of non-ideal solutions and negative deviation of non-ideal solution or ideal solution, like that. Listen, the next one, non-ideal solution. So after learning ideal solution, non-ideal solution, those definition, now observe this non-ideal solutions is again classified into two types, that is positive deviation and negative deviation. Non-ideal solutions are classified into two types, that is positive deviation from Rhodes law and negative deviation from Rhodes law. Positive deviation from Rhodes law and negative deviation from Rhodes law. These are the two types of non-ideal solutions. These non-ideal solutions are classified into two types, that is positive deviation from Rhodes law and negative deviation from Rhodes law. So observe here, ideal solution means the solution which obey Rhodes law under over the range of all concentration, and non-ideal solution means the solution which do not obey Rhodes law over the range of all conditions or concentrations. Now these non-ideal solutions into two types, positive deviation and negative deviation. Here the non-ideal solution which shows higher deviation from Rhodes law is called positive deviation of non-ideal solution, and the solution which shows less deviation from Rhodes law is called negative deviation of non-ideal solution. Means the solution which shows higher deviation from Rhodes law. Rhodes law is called what? Positive deviation of non-ideal solution. Similarly here the solutions which shows lesser deviation from Rhodes law is called what? Negative deviation from Rhodes law. Now for for positive solutions, delta H of mixing is greater than 0 and delta V of mixing is also greater than 0. You know, for non-ideal solution, delta H of mixing and delta V of mixing, that is enthalpy change and volume change of mixing is not equal to 0. It means greater than or less than 0. Such type of solutions is called what? Non-ideal solution. Those into two types. If it is greater than 0, we call what? Positive deviation of non-ideal solution from Rolle's law. If delta H of mixing is less than 0 and delta V of mixing is less than 0 is called negative deviation from Rolle's law. Now for example, for positive deviations, take delta H of, example for positive deviation is take acetone and ethane. For negative deviation, take chloroform and water. These are the best example for positive and negative deviation. Now observe, in this positive and negative deviations, the delta H is exothermic. Not exothermic, this is endothermic. So delta H is exothermic. In positive delta H is exothermic, and here delta H is endothermic. So here absorption of heat takes place, here liberation of heat takes place. So observe, for example, in the case of positive deviation from the Rolle's law, let's take a compound A, acetone and ethane. So you know the molecular formula of acetone. For positive deviation, you know acetone and ethane. Take acetone, CH3, C double bond O, CH3. This is acetone, and take ethane. Ethane is nothing but CH2, a CH3 bond CH2. Sorry, not ethane, ethanol. Take ethanol, that is CH2OH. So this is the ethanol and this is acetone. Now in this acetone molecule, this one of the acetone is make a bond with, means in ethanol one of the ethanol molecule make a bond with, means hydrogen bond with one more molecule of hydrogen of ethane, like that. ಹೈಡ್ರೋಜನ್ ಮತ್ತೆ ಆಕ್ಸಿಜನ್ ಮಧ್ಯೆ ಒಂದು ವೀಕ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಅನ್ನೋದು ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಎಥನಾಲ್ ಅಲ್ಲಿ. ಆದ್ರೆ ಅಸಿಟೋನ್ ಅಲ್ಲಿ ಆ ತರ ಫಾರ್ಮ್ ಆಗೋದಿಲ್ಲ. ಲೆಟ್ ಟೇಕ್ ದಿಸ್ ಇಸ್ ಎ ಕಾಂಪೋನೆಂಟ್ ಎ ಅಂಡ್ ದಿಸ್ ಇಸ್ ದಿ ಕಾಂಪೋನೆಂಟ್ ಬಿ. In a component A, there is a AA bond interaction. In a component A, there is a A and A bond interaction. Similarly, in the component B, there is a B and B bond interaction. On mixing both the acetone and ethanol will get a mixture of acetone and ethanol. In that case, means while mixing, some of the bonds, means hydrogen bonds present between the ethanol is broken and occupies the interstitial position of ethanol into the acetone. Therefore, the volume of the solution is increases after mixing the acetone and ethanol. This is happening in the positive deviation. Hence, the vapor pressure of ethanol is increases than that of the vapor pressure of pure ethanol. So observe ಮಾಡಿ ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದೀನಿ ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್ ಅಲ್ಲಿ ನಾವು ಎಕ್ಸಾಂಪಲ್ ಏನು ತಗೊಂಡಿದ್ದೀವಿ, ಅಸಿಟೋನ್ ಮತ್ತೆ ಎಥನಾಲ್ ತಗೊಂಡಿದ್ದೀವಿ. ಅಸಿಟೋನ್ ಅನ್ನ ಎ ಅಂತ ತಗೊಳ್ಳಿ, ಎಥನಾಲ್ ಅನ್ನ ಬಿ ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ, ಕಾಂಪೌಂಡ್ ಎ ಕಾಂಪೌಂಡ್ ಬಿ ಅಂತ. ಸೊ ಅಸಿಟೋನ್ ಅಲ್ಲಿ ಎ ಬಾಂಡ್ಸ್ ಇರುತ್ತೆ, ಅಂದ್ರೆ ಒಂದು ಅಸಿಟೋನ್ ಇನ್ನೊಂದು ಅಸಿಟೋನ್ ಬಾಂಡ್ ಆಗಿರುತ್ತೆ. ಅದೇ ರೀತಿ ಎಥನಾಲ್ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಬಿ ಮತ್ತೆ ಬಿ ಅಂತ ಒಂದು ಅಸಿಟೋನ್ ಇನ್ನೊಂದು ಅಸಿಟೋನ್ ಪಕ್ಕದಲ್ಲೇ ಇರುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಇವೆರಡರ ಮಧ್ಯೆ ಏನಾಗುತ್ತೆ, ಬಾಂಡ್ ಅನ್ನೋದು ಇರುತ್ತೆ, ಸ್ಟ್ರಾಂಗ್ ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಅಟ್ರಾಕ್ಷನ್ ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಏನಾಯ್ತು ಅಂದ್ರೆ ಎಥನಾಲ್ ಅಲ್ಲಿ ವೀಕ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗಿರುತ್ತೆ. ಯಾಕೆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಆಕ್ಸಿಜನ್ ಹೈಡ್ರೋಜನ್ ಇರೋದ್ರಿಂದ here there is a weak bond interaction between means hydrogen bond interaction between one molecule of ethanol into the one more molecule ಒಂದಕ್ಕೊಂದು ಇಂಟರಾಕ್ಷನ್ ಇರುತ್ತೆ. when we are mixing A into B, A ಮತ್ತೆ B ಎರಡು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಈ B ಯಲ್ಲಿರುವಂತ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ಸ್ ಬ್ರೇಕ್ ಆಗಿಬಿಟ್ಟು A ಅನ್ನೋದು ಹೋಗಿ ಅದರ ಮಧ್ಯದಲ್ಲಿ ಸೇರ್ಕೊಳ್ಳುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಸೇರ್ಕೊಂಡಾಗ ಏನಾಯ್ತು ಅಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಅನ್ನೋದು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಬರುವಂತ ಕಾಂಪೌಂಡ್ ನ ವಾಲ್ಯೂಮ್. ಆಫ್ಟರ್ ಮಿಕ್ಸಿಂಗ್ ಯು ಗೆಟ್ ಎ ಕಾಂಪೌಂಡ್ ಲೈಕ್ A and B, right? This volume is increases. That says the volume of a solution is greater than volume of a solute and solvent. Here you can say that volume of solution is greater than volume of solute and solvent. ಸಲ್ಯೂಟ್ ಮತ್ತೆ ಸಾಲ್ವೆಂಟ್ ನ ವಾಲ್ಯೂಮ್ ಅನ್ನೋದು ಜಾಸ್ತಿ ಕಡಿಮೆ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ಬೋದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಎ ಅನ್ನೋ ಕಾಂಪೌಂಡ್ 9 ml ತಗೊಂಡಿರ್ತೀರಾ, ಬಿ ಅನ್ನೋ ಕಾಂಪೌಂಡ್ 5 ml ತಗೊಂಡಿರ್ತೀರಾ. ಆಫ್ಟರ್ ಮಿಕ್ಸಿಂಗ್ ದೀಸ್ ಟು ಯು ಗೆಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ 15 ml ಆಫ್ ಕಾಂಪೌಂಡ್ ಎ ಬಿ, ರೈಟ್? 9 ಅನ್ನೋದು ಎ ಅನ್ನೋ ಕಾಂಪೌಂಡ್ 9 ml, ಬಿ ಅನ್ನೋ ಕಾಂಪೌಂಡ್ 5 ml ತಗೊಂಡಾಗ ಎರಡು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ 15 ml ಬರಬೇಕು. ಹಾಗೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಯು ಗೆಟ್ ಗ್ರೇಟರ್ ದೆನ್ 15 actually means by practically you get greater than 15. This is due to breaking of intermolecular hydrogen bond in ethanol and occupies the between this acetone molecule. Hence the volume of resultant compound is increases and the vapor pressure also increases. ಇದರಿಂದ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಅಸಿಟೋನ್ ಅನ್ನೋದು ಅಥವಾ ಎಥನಾಲ್ ಅನ್ನೋದು ಬೇಗ ಎವಾಪರೇಟ್ ಆಗ್ತಾ ಇರಬಹುದು, ಯಾಕೆಂದ್ರೆ ಒಂದಕ್ಕೊಂದು ಮಾಲಿಕ್ಯೂಲ್ ಮತ್ತೆ ಇಂಟರ್ನಲ್ ಅಟ್ರಾಕ್ಷನ್ ಇರೋದಿಲ್ಲ. ಓಕೆ, ಸಿಮಿಲರ್ಲಿ ಇನ್ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ಸೊಲ್ಯೂಷನ್ ಲೆಟ್ ವಿ ಟೇಕ್ ಕ್ಲೋರೋಫಾರ್ಮ್ ಅಂಡ್ ವಾಟರ್. ಕ್ಲೋರೋಫಾರ್ಮ್ ವಾಟರ್ ತಗೊಂಡಿದೀವಿ. ಈಗ ದಿ ಕ್ಲೋರೋಫಾರ್ಮ್ ವಾಟರ್ ಬೋತ್ ಆರ್ ಮಿಕ್ಸಿಂಗ್. ಕ್ಲೋರೋಫಾರ್ಮ್ ವಾಟರ್ ಎರಡು ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ. ಒಂದು ಎ ಅನ್ನೋ ಕಾಂಪೌಂಡ್ ತಗೊಳ್ಳಿ, ಕ್ಲೋರೋಫಾರ್ಮ್ ಅನ್ನೋದು ವಾಟರ್ ಬಿ ಬಿ ಅಂತ ತಗೊಳ್ಳಿ. ಎರಡು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಆಫ್ಟರ್ ಮಿಕ್ಸಿಂಗ್ ಕ್ಲೋರೋಫಾರ್ಮ್ ವಾಟರ್, ಸೊ ಅಬ್ಸರ್ವ್ ದಿಸ್ ಇಸ್ ಕ್ಲೋರೋಫಾರ್ಮ್ CH Cl3, this is chloroform, and water H2O. water ಇವೆರಡು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಏನಾಯ್ತು ಅಂದ್ರೆ a bond is formed between water and chloroform. ವಾಟರ್ ಮತ್ತೆ ಕ್ಲೋರೋಫಾರ್ಮ್ ಮತ್ತೆ ಒಂದು ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಯಾವ ತರ ಅಂದ್ರೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಕಾರ್ಬನ್ Cl3 ಹೈಡ್ರೋಜನ್. ಈ ಹೈಡ್ರೋಜನ್ ಅನ್ನೋದು ಆಕ್ಸಿಜನ್ ಅಲ್ಲಿ ವಾಟರ್ ಅಲ್ಲಿ ಇರುವಂತ ಬಾಂಡ್ ಜೊತೆ ಏನಾಯ್ತು ಒಂಥರ ವೀಕ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಈ ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ ನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಎರಡು ಸೊಲ್ಯೂಷನ್ಸ್ ಅನ್ನ ಮಿಕ್ಸ್ ಮಾಡಿದ್ಮೇಲೆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಯ್ತು ಅಂದ್ರೆ ಏನಾಯ್ತು, ವಾಲ್ಯೂಮ್ ಅನ್ನೋದು ಕಡಿಮೆ ಆಗುತ್ತೆ, ಒಂದ್ರ ಮಧ್ಯೆ ಒಂದು ಕಡಿಮೆ ಆಗ್ಬಿಟ್ಟು ವಾಲ್ಯೂಮ್ ಅನ್ನೋದು ಕಡಿಮೆ ಆಗುತ್ತೆ. ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಆಯ್ತು ಅಂದ್ರೆ ಬೇಗ ಎವಾಪರೇಟ್ ಆಗೋದಿಲ್ಲ. ಹೀಟ್ ಅನ್ನೋದು ಸಪ್ಲೈ ಮಾಡಿದ ಮೇಲೆ ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಿಬಿಟ್ಟು ಸಾಲ್ವೆಂಟ್ಸ್ ಅನ್ನೋದು ಎವಾಪರೇಟ್ ಆಗುತ್ತೆ. ಸಚ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಕಾಲ್ಡ್ ವಾಟ್ ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ಸ್, ಮೀನ್ಸ್ ನಾನ್ ಐಡಿಯಲ್ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ಸ್. ಅದೇ ರೀತಿ ಮೊದಲೇ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗಿದ್ದಾಗ ಅದು ಬ್ರೇಕ್ ಆಯಿತು ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ಸ್. ಓಕೆ, ದಿಸ್ ಈಸ್ ದಿ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಐಡಿಯಲ್ ನಾನ್ ಐಡಿಯಲ್ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ಫ್ರಮ್ ರೋಡ್ಸ್ ಲಾ ಆಫ್ ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಅಂಡ್ ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್ ಫ್ರಮ್ ರೋಡ್ಸ್ ಲಾ ಆಫ್ ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ಸ್. ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಕೇಳ್ತಾರೆ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ಸ್ ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಡೆಫಿನೇಷನ್ ಅಂಡ್ ಆಲ್ಸೋ ಡಿಫರೆನ್ಸ್. what is the happening inside the solution. Okay, two components when we are mixing both solute and solvent, either it may be volatile or non volatile. Okay.